Hi everyone. So in this video we're going to be looking at alkenes and the properties of alkenes in terms of addition reactions. So let's look at alkenes. So alkenes are hydrocarbon, which means that they contain carbon and hydrogen atoms only, so there's no other atom in it. And alkenes, the homologous series alkenes, when you're naming it, so alkenes here, they end with "ene." So when you're naming it, the same principle will apply. So if there is 2 carbon, the name will start with eth. If there's 3 carbon, so prop. 4 carbons, but. 5 carbons, pent, and so on and so forth. And they will all end with "ene. So propene, butene, and pentene, they all end with "ene." And they all contain CC double bonds, and the CC double bonds, this is the functional group of alkenes, CC double bond. And molecules which contain double bonds are said to be unsaturated molecules. And because of the CC double bond, this is going to allow the molecule to undergo very specific reactions. So if you remember, I told you that the functional group, this is what determines what kind of reactions it will undergo. And alkenes, they undergo specific reaction called addition reaction to the CC double bond. So alkenes are said to be unsaturated molecules. Alkanes are said to be saturated molecules. So there is one tip that I used to remember this, because sometimes we do get confused which one is saturated, which one is unsaturated. So that's the tip that I use. So alkanes are surrounded, so that's ethane and that's ethene. So alkanes are surrounded, the 4 regions of carbon are completely surrounded. So we could see that the carbon is saturated with bonds around it. So the region around carbon is all filled up. So that's called saturation. It's like is kind of fed up of having all the hydrogen around it. But if you look at an alkene, so there's just 3 regions around the carbon that is taken up with the hydrogen. So it's unsaturated. There's still some more that you can add on here. So that's what I use to remember a bit about saturated and unsaturated. There is nothing scientific here. It's just one way to remember it. So propene, now how we draw the displayed formula. So I'm going to start with the carbon backbone. So there's 3 carbon. There should be a double bond between them. So I'm going to put the double bond here. You can put it anywhere you want. It doesn't really matter as long as it's between the carbon atoms. And I'm going to fill the rest with hydrogen. And I'll start with a carbon 1. And remember that the carbon should be surrounded by 4 bonds. So carbon 1 has already formed 2 bonds. So 2, 3, 4. Carbon 2. So this is a double bond, the other one is going to be a single bond. Carbon 2 is already forming 3 bonds, so there's going to be a 4th one here. And carbon 3 already forms 1 bond, so 2, 3, 4. And if you count, you'll see that there is 3 carbons and 6 hydrogen. Let's do for the other one. So butene, there should be 4 carbons, 1, 2, 3, 4. I'm going to place the double bond, and the others are single bonds. Okay, and I'm going to fill up with hydrogen. First carbon already forms 2 bonds, 3, 4. Second carbon is already forming 3 bonds, 4. third carbon is already forming 2 bonds, 3, 4, and fourth carbon is forming 1 bond, so 2, 3, 4. No need for you to show the carbon numbers when you are drawing that. It's just for me to explain. So if you count, so C4H8. So if we do for pentene, so you will have 5 carbons in the backbone, 1 double bond, and you fill up with the hydrogen. I leave that up to you, and as well for the 6 carbon member. So what you can note about the alkenes, so the first thing is that there is no member with 1 carbon. So number of carbon atoms starts with 2. Of course it's going to start with 2 because you need to have a CC double bond, and you can't have a double bond if there's just 1 carbon. So there is no member with 1 carbon for alkenes. The second thing is that if you look at the members, so if you have 2 carbon, you'll have 4 hydrogen, 3 carbon, 6 hydrogen. So you see that one way to represent the formula would be CnH2n. That is the general formula for alkenes. So you can find any molecular formula. So if there is, let's say, 8 carbon, means there's going to be, so C8H16. If you have 20 carbon, so C20H40. So you can find the molecular formula of any hydrocarbon, of any alkene, using the general formula. And the third thing that we can note, so if you have 1 alkene here, so if you add CH2, so you end up with C3H6. So if you add CH2, you end up with C4H8. So the members differ by each other by a CH2. So successive members differ by a CH2. So these are the 3 things about alkenes. Now, reactions that alkenes undergo combustion reaction and addition reactions. And these are the only 2 reactions that alkenes will undergo. And just like alkenes will undergo 2 types of combustion. So there is either complete combustion when there is excess of oxygen, or incomplete combustion where there is limited amount of oxygen. And complete combustion will give you carbon dioxide and water vapor, while incomplete combustion will give you carbon and water vapor, or carbon monoxide and water vapor. So watch out for the words limited amount or excess oxygen for you to know if it's complete combustion or incomplete combustion. I'm going to do the equations for ethene first, and then you're going to do for the rest. So ethene reacts with limited amount of oxygen, so that's incomplete combustion, to give you carbon monoxide and water vapor. Whenever it's incomplete combustion, they will usually tell you the product. Usually, but you need to know that you will have carbon or carbon monoxide. And we'll balance the equation. To balance the equation, always start with a carbon. For these kinds of reactions, start with a carbon, then with the hydrogen, and last you're going to balance the oxygen. So 2 plus 2, that's 4, so I'll put a 2 here. It did not ask you for the state symbol, so no need to include it. Include it only when you are asked to write it down. So here you have excess oxygen, so that's complete combustion, so it's going to give you carbon dioxide and water. And if you balance it, again balance the carbon first, then you balance the hydrogen, and then you're going to balance the oxygen. So 2 times 2 is 4 oxygen plus 2, that gives you 6 oxygen, so I'll put a 3 here. Okay, and you are going to complete these 2 in the worksheet. Now, addition reactions, that's the second kind of reaction that alkenes undergo, and addition reactions will take place across the C double bond C, and there's going to be only one product formed during addition reactions. These are the three types of addition reactions that take place. So let's see a summary of this. Now, alkenes, so let's take ethene for example. Alkenes will undergo addition reactions with molecules that look like this, so AB molecules, and this can be anything, so it can be bromine, can be anything among these three, so bromine, so BR, HH, and H2O, where you could take this as, let's say that's B, and that would be A. So what happens in an addition reaction is that one of the atoms or group of atoms, so one of it is going to fit on to the first carbon and the other is going to fit on the second carbon, and that double bond here is going to break open. Okay, so which means that you'll end up, so you have the same backbone, but you end up with A being attached to one carbon and B being attached to another carbon. So that double bond breaks open, and it doesn't matter which one goes to which carbon for now, so you just need to break it open. So the first reaction is with bromine, so reagent is bromine, or you could use bromine water, which is also called aqueous bromine. So bromine water. Conditions, so condition is room temperature and pressure. And let's see the reaction. So you're going to have ethene, so that's ethene, 2 carbons and 4 hydrogen. So reacting with bromine, so this is what you have. So one of the bromine is going to add onto one of the carbons across the double bond, and the other is going to add to the second carbon across the double bond, so that you end up with, so that's the backbone, and you have the bromine that adds onto each carbon. So this molecule here, this is called dibromoethane. Why dibromo? Because there is 2 bromine, and ethane because it is a saturated molecule. So ethane, so this is why we use the alkane backbone, because it's saturated. So dibromo, there's 2 bromo, 2 bromine. Okay, so now second reaction is addition with hydrogen. So for this we're going to use hydrogen gas, and the condition is 200 degrees Celsius nickel catalyst, and we'll have the corresponding alkane that is formed. So let's see. So one of the hydrogen adds here and the second adds in here, so you end up with, so this is what you have. So with an alkane, so that's going to be ethane. Okay, so ethene plus hydrogen is going to give you ethane. So that's for the addition of hydrogen. So hydrogen adds across the double bond. Let's see the addition of steam now. So here the reagent is going to be steam. So it's just water at very high temperature. So because it's 300 degrees Celsius, so it's going to be steam, 70 atm pressure, and phosphorus acid catalyst. So let's see the reaction. So you have the ethene and the steam reacting. You can either show it like this or you can show it like this. It doesn't make really a difference. It's just that we're considering this as one block, so that when it adds, this is going to add here and this is going to add here. Which carbon adds to which atom or groups of atom doesn't matter for now. So you'll end up with this molecule. So you see the double bond breaks open and accommodates the new atoms or groups of atoms. So they are adding onto the alkane molecule. Now, just one thing for you to note here, when you're showing the displayed formula, be careful. The carbon is bonded to the O, which is bonded to the H. So if you would expand it, it would be like this. So please do not write C OH bond like this, because the carbon is not bonded to a hydrogen. A hydrogen cannot form two bonds. So this is wrong. So it's not the hydrogen that bonds to the carbon, it's the oxygen that bonds to the carbon. So this is how you represent it, and not like this. Okay, so this is wrong. So this molecule here, this is called an alcohol. So there's two carbons, so we'll call that ethanol, because alcohols end with ol. So ethanol molecule. So this is what you have, ethene plus steam, you get ethanol. Ethene will give you ethanol. If you start with propene, you will get, with steam, you will get propanol. If you start with butene, you will get butanol. Similarly here, if you're starting with propene, you would get, with hydrogen, you will get propane. If you start with butene, you will get butane. If you start with hexene, you will get hexane. So it's the corresponding, here is the corresponding alkane, and here it's the corresponding alcohol that is produced. Now, let's see differentiation between alkene and alkanes. So if you're provided two samples of hydrocarbons, and you need to know which one is the alkane and which one is the alkene, you can test it with aqueous bromine. So in the presence of aqueous bromine or bromine water, an alkene is going to produce the dibromoalkane, and in this reaction you see decolorization, because bromine water is brown, so you could say orange or brown. And when the reaction takes place, so at this point it's orange or brown, and after the reaction this one is colorless. So when you have a double bond present, bromine water turns colorless because of the addition reaction. But if you have an alkane present, there is no addition reactions that take place. So you will still have that brown color that remains. So there will be no change in the color. So that's the differentiation that we use. Let's fill up this table. So for ethane, no change in color because there is no double bond C and there's no new products. But when you have ethene, you have color change from brown to colorless. This is called decolorization because it has a CC bond and that an addition reaction takes place, and you have dibromoethane as the products. So this is the differentiation of alkene and alkane. Now you're going to work out these questions in your handouts or in the document attached that I'm going to correct. So thank you, and that's it for the